Okay, there it's going. Okay, so now what you want to do in Desmos, you're just going to go up here and you have to make a table of X and Y values to use for the regression.
Okay.
So you click on this little plus button up here and you'll see table. Okay. And then you're going to notice that you're going to have this. This is the start of a table. These are going to be the X values, and this column will be the Y values. Notice that the X values are X1 and the Y values are Y1. That little subscript 1 is telling us that these aren't variables. These are specific values of X and Y. Okay. I'm just going to make some up here for you. So like, what if we had X values of 1, 2, and 3? And let's just say, I'm going to make up some Y values. Let's just say they were 0, 4, and 7, something like that. And you'll notice over here that these points will show up on Desmos that I just plotted.
Okay.
Okay. Now, to get regression, all you've got to do is this. All you've got, in fact, I'm going to put in one more too while I'm at it. Whoops. I'm going to do 4, and I'm going to do, should have been 8, 12, so I'm going to do 13. And then if I just zoom out a little bit, I can see all those points right there. Not that I even have to, okay? Now, when I want to do regression, here's how you do it. I'm going to come down and I'm going to make an equation with X1 and Y1, a linear equation. So we would just use slope-intercept form, right? Y equals mx plus b. But instead of y, I have to use y1. So I'm just literally going to type y followed by a 1. And Desmos is smart. It knows to make that a y sub 1. And instead of an equals, I have to use a tilde, which is, if I hit shift, it's just to the left of the 1 on the keyboard. It's like that little squiggle right there.
Yeah.
Okay. So I'm going to do y1. And what that means is it's regressed against this equation. So it's going to be y1 tilde instead of equals m, and then I need an x1 instead of an x. Okay. So there's mx plus b. And look what it does. It does something really cool here. I'm going to make this a different color so we can see it better. I'm going to make this red. Okay. Look, it gives me this red line, and that red line is the line that best fits that distribution of points that we have. It's what we call the best fit line.
Okay.
It tells me some important things here. It tells me what the values of m and b are. So the best fit line for that data is the line y equals 4.2x minus 4.5. If I plug those values in for m and b, that's my answer.
Okay.
Okay. This little this strength of correlation up here, this r squared, this 0.98. That's telling me, if I think of that as a percentage, this is just kind of a good way to think about it. It's saying that's a pretty good fit. It's about 98% accurate. Okay. Like if I had some other points, like if this point were something like a 1 instead, now look at that line doesn't fit those points very well, does it? And so look what happened to my strength of fit. This one's only 6% accurate. It's a horrible fit, right? Okay. You get the idea?
Yeah.
Okay. So that's all they're wanting you to do.
Okay.
Okay. And now if you want to do a different, like they'll have you do some other types of regression. Like they might have you do a quadratic regression. Well, that's okay. I can just come down here with that same data table. If I want to see how well that fits a quadratic, so a parabola, I just come down here and I'm just going to change my regression equation. Let's do y equals ax squared plus bx plus c. That's just our standard form for a parabola. So I would just do a x1 squared plus b x1. I have to use x1 and y1 plus c, and look what it does. Now it's gonna match those points with the best possible parabola, which is this parabola right here, where a is equal to 0.5, so it'd be 0.5 x squared plus 1.7x minus 2. And it fits those pretty well. It's actually over a 99% fit. Okay, does that make sense?
Yeah.
Okay, I'm going to add one more point here. I'm going to do just a cubic, and then maybe this will get you going on stuff. Okay, so I'm going to say Actually, I'm going to make this -2, oh, I don't know, it doesn't matter, 5, something like that. Now, notice when I added that extra point, now the parabola doesn't fit quite as well. It's only 98%, right?
Mhm.
98.3%. So we might think, okay, let's try cubic. Okay, that's okay. For a cubic, I would just make, I'm adding an extra term. So that would just be ax cubed plus bx squared plus cx plus d. Okay, if we want to fit that to a cubic polynomial. So I would just go, here, I'm just going to tweak these things and make that a cubed. I'm going to make this one squared. I'm going to make that cx plus d. Oops, I forgot to see what I did. I forgot to put x1 there.
Yeah.
There we go. So now there's my best fit cubic, and it's maybe a little bit better, but there it is. It tells me the
Mhm.
values A, B, C, and D that I would plug in up there. Okay.
Yeah.
Okay, that ought to make that whole section a lot easier.
Yes, that helps a lot.
Okay, good. So here's what I'll have you do then. Why don't you just go try this? And if you're
Okay.
having issues, shoot me an email. I'll be on for a little bit today. I've been on all morning, and I've got some meetings coming up, and I've got to do a couple. I've got some other. I got to make some contacts and things with some parents. So I may not be available this afternoon, but I will be tomorrow morning. If
Okay.
you send me an email, I might even be able to help you out, like send you a link or something through the email. But I bet you'll be fine.
Okay.
And then just work ahead until you come to another issue, and then let me know as soon as you do.
Okay.
Does that sound good? Are you feeling a little better about things
Yeah,
now?
I am.
Good, good. All right. Well, I'm glad we touched base, because if this happens again, just let me know. Look how quick it is. I can help you.
Yeah.
All right.
Thank you.
Okay. Good seeing you, Mackenzie.
You
Good luck
too.
with all this stuff.
Okay. Bye.
All right. Bye.